Howdy, we are Mercury Integrated Systems, and this is our project Smart Trailer. Our team consists of Evan McCaig, project manager, myself, Lauren Hale, hardware engineer, Jamel Gaines, software engineer, and Jonathan Burney, systems integration engineer. Our primary stakeholders are Dr. Ben Zogi, our sponsor, and Dr. Logan Porter, our technical advisor. For a little background, many automobile companies are using sensors to improve the safety and efficiency of their vehicles, but the trucking industry is one of the last to adapt to these modern technologies. Alone, the trucking industry accumulates around 27 million in fines every year, and preventable failures can cause expensive downtime for a trailer. So fleet owners and drivers need a solution that monitors trailer safety systems with a user-friendly driver inspection tool. The smart trailer will outfit a semi-truck trailer with various sensors that allow the truck driver and end user to monitor the health of their trailer through a driver-friendly mobile application. The smart trailer will improve safety, security, and cargo assurance. The smart trailer will function with real-time data transmission. It will be reliable, long-lasting, and user-friendly. This product is intended for fleet owners, semi-truck drivers, as well as research students. A completed and working product will utilize 4 different types of sensors to monitor the trailer's internal light, temperature, shock sensitivity, and door access. Data collection and transmission of those measured values will be sent using BLE5. Successful processing of each sensor's data, central intelligence module that can transmit and receive Bluetooth data, and a mobile app that will receive communication from the central intelligence and provide user-friendly display. Here you can see our conceptual block diagram. So in the trailer, we'll have sensors that collect temperature, door, light, and shock data, and those sensors will each send over Bluetooth 5 information to central intelligence. Central intelligence groups the data, uses battery power, then sends that over Bluetooth to a mobile phone, which displays the data here in an easy to see and understand mobile application. Here you'll see our functional block diagram. So at the bottom, on either side of a central intelligence, we have groups of sensors. So you'll see 2 sensors to the left for shock and temperature, and 2 sensors to the right for door and light. This just groups all of these to show that they send Bluetooth data to the central intelligence, which then again sends Bluetooth data to a mobile phone. Everything is powered using 2 1.5 volt AA batteries, so everything gets a maximum 3 volt power input, but most of our parts work down to 1.7, 1.5 volts. So mechanical overview, you see at the nose of the truck closest to the cab, we have an antenna mounted on the outside, which is connected to the central intelligence on the inside, as well as an antenna mounted on the inside connected to the central intelligence as well. Then you'll have temperature and light sensors mounted at the top of the trailer, and shock and door sensors also mounted at the top and close to the door at the end of the trailer. So this video shows a full system prototype where we've decided to place all of our sensors. So here is the cab where the driver would be with the mobile phone and application running. Here's where we've mounted our outside antenna. So this is to get data from the inside of the trailer to the outside so that the phone can pick it all up. Then as we go to the back of the trailer, we'll open it up and take a look at all the sensors we've placed inside. So here, right on the door, we have mounted a magnet, and then we have our door sensor. So every time the door is closed, you'll be alerted. And if the door is open, you'll be alerted. Then there's our shock sensor. Here you'll see our light sensor mounted at the top. There's a little window so that the sensor can see light in the trailer. Then further down the trailer, we have our temperature sensor also mounted up top to stay out of the way of cargo loads. And lastly, inside the trailer, you'll see a cable running from the outside that's connected to the central intelligence, which is using a cable splitter to then also be connected to an internal antenna. Here's our mobile app dashboard. So on the left, you'll see our lock screen. So once the user enters a PIN, it opens up to the normal status dashboard. And then if the temperature is too high, you'll see what looks like in error example 1. The door is open, there's excessive motion, and the light status has changed. So those are all what the alerts look like. When the temperature is too low, you'll see what it looks like on the very far right. So here's a video that shows our functioning system. So the user is in the cab of the truck, and he has the app open that you see on the left. He's entering in the passcode. So as the door is going to close, you will not only see the door status change, but also the light status. Once the light status changes, it'll stay alert for a little bit and then go back to normal like you see now. And then as the door opens again, the door status will change and the light status will change again. And in this demonstration, you will see our shock status get triggered. So we lowered the threshold so that we didn't have to drive rough for testing, but essentially the motion status will remain null until some excessive rough driving is detected. So here you'll see we went over a bump and it's detected excessive motion. So the impact of Smart Trailer would ultimately lead to safer roadways, truck driver accountability, real-time responses, as well as legal compliance. In conclusion, Smart Trailer is a system that monitors trailer conditions for companies and drivers, providing a system that encompasses 4 BLE5 sensors to capture the trailer status and present it on a user-friendly mobile application. Thank you for watching. This is Mercury Integrated Systems with our Smart Trailer.